Hey guys, welcome again for a new session on Find Automata. Okay, last class we guys have been discussed on something called a DFA, Deterministic Finite State Automata, and this class will be discussing something called as NFA, called a non-deterministic finite automata. Okay, automata or automaton both mean the same. Okay, first let me give an example for you, and then I just thought of sharing you like how exactly the given things works. For example. Here, I'll be taking set of alphabets, and currently, to brief you out with a good example, I'm taking only one alphabet as an A. Okay, currently, I'll be starting with a state called Q naught. I use the symbol A to it. If I use the symbol A, I'm going to a two states called as a Q1 and Q3. Okay, then in a Q1, I use an A, I'm going to a Q2. Just assume this as my example for it. Okay, now the question goes like this. Sir, I'm in a state called a Q naught. I get a symbol called A. What I have to do? I do have two choices, and that choices are either I can go for Q1 or I can go for a Q3. And if you observe the things properly, in a state called Q2 and Q3, there is no transaction in it. As the deterministic finite automata says, for each and every says, all symbols must be used. In a state called Q3 and a Q2, the symbols are not being used. So what this diagram is called as, and this is called as an NFA. I'll just take a string for you all and start explaining to it. Okay. For example, my upper place says me a string. Here I'm taking a two string called as AA, and I start tracing for it. Okay, as you guys know how to trace a given program, yep, I start with a state called a Q naught. I use the symbol A, then I go to a state called Q1, then I use my next symbol A, then I go to a state called Q2. As my string is A and A, I've been to a final state and my machine is accepted. Correct? Yes. The two string A and A, I'm in a final state and hence the string holds good. Okay, now let me take one more scenario. I'm in a state called Q naught. I use the symbol A, then I go to a state called Q3. Do I have a chance to take another symbol? No, because in a state called Q3 there is no transaction and hence this get rejected. Clear? Let me means the given diagram I will represent in two phase. If you observe the right and the left one says an accepted string and one says a rejected string. But as per the given string says A and A must holds good, and this scenario is called as an NFA scenario. Okay, let me take a few more things as an example. I've been taking the same diagram. I've been taking one more example. Now I'm taking three A's in it. Okay, let me assume I'll go on top. In A, I'll go to a state called a Q1. Then one more A, I go to a state called Q2. I've been rejected. Any idea why I've been rejected? The reason is I do have one more string. But I'm in a final state. But in this final state called Q2, there is no transition. When there is no transition, what else we can do? It says that I'm in rejection state or my automata has been halt. Correct? And this is the thing. If I go with the second choice, I can get only one A. Again, my automata has been halted because there is a two more A left. And this scenario is called as a NFA, non-deterministic. I meant to say I can never determine what happens when I get a symbol in a particular state. Now define what exactly you mean by NFA. NFA stands for a non-deterministic finite automata. Here again, NFA has a 5 tuples and Q, sigma, delta, Q naught and F. Q stands for a number of states, sigma stands for a number of symbol, a delta again stands for a transition. But if you observe the delta properly, here the delta Q summation with sigma, it can represent 2 to the power of Q states. I meant to say, if I take any states, there may be n number of probabilities, and hence we get 2 to the power of Q is a transition function in an NFA diagram, where a Q naught represent a starting state, F represent a final state. Clear? Where 2 to the power of Q is a set of subsets, where Q and a sigma is a union of it. Clear, guys? Okay, this is a one type, as has already been explained. DFA contains automata contains 3 types of a machine. One is a deterministic finite automata, one is a non-deterministic finite automata, and next one is an epsilon automata. Clear? Okay, now Deterministic is been done definition, non-deterministic definition is been done. Now today's class I'll be explaining only about a definition. Okay, now let me explain a definition of a non-deterministic finite automata. Okay, now RE stands for a regular expression for an epsilon NFA. What is an epsilon NFA? Yes, going with a fluent example, I will explain epsilon. Epsilon meant to say I'll be in a state called one state and I'm going to another state by using a symbol. It's called transition by taking a symbol. Okay, and there's one more scenario. I'm in a state without taking any transaction. I can go to another state, and that is called as an epsilon. For example, if you observe the things properly, my first point says I use the symbol A. I'm in one state. If I use the symbol A, I'm going to my second state. Clear? Okay. Now epsilon. I'm in a state. Epsilon meant to say it is called as a pass or a push. Okay, means either I take a symbol or I don't take a symbol, I will be going from one state to another state. Okay, now with that regards, I've been explained the null also. What do you mean by null? Null meant to say there is no transition. Many will get confused with epsilon and null. Epsilon meant to say I'm flowing from one state to another state without any symbols in it. It's called an epsilon. Null meant to say I can never transaction between one state to another state. It's called as an epsilon NFA. Okay, now the thing it goes like this. We can allow the state to state transition on an epsilon input. This transition not been done simultaneously without looking at any input. For example, any strings comes, if an epsilon is there, I'll directly pass from one state to a state till I get a state where I have a transition. A convenience at time, but still only regular languages are accepted in an epsilon. This meant to see, this doesn't mean to say, sir, if the input symbol are not been present, even it will run. No, this has to be in a regular language. Then only this machines will look. Okay, now many have got an ambiguity, confusion. Sir, I'm not able to get what that exactly an epsilon NFA is. I've been taken a diagram on left side and a transition table on my right side, and I hope you guys know what you mean by a transition table. Okay, here there are a set of states. I name it as A, B, C, D, E, and F. And a set of symbol I name it as 0, 1, and an epsilon is also one symbol form. This is called an epsilon NFA. Here, I repeat, this is a diagram which says an epsilon NFA. How to identify a diagram as an epsilon NFA? Simple. A transaction where epsilon has been included to it, and that thing I represent as an epsilon NFA. Okay, now let me start tracing the given thing. I'm in a okay, you observe the transition table, guys. Observe only this transition table. Okay, I'm in a state called A. I get a symbol 1. I'm going to B. I'm in a state called A. I'm getting a symbol 0. I'm going to E. Correct? 8, 0 is E. A to 1 is B. I'm in a state called A where my epsilon I get a transaction. Where am I going? I'm not going anywhere, and hence I represent null. Is that clear? Okay, now let me go with one more thing, guys. Okay, I'm in a state called B. I use 0. I'm in a state called B. I use 0. Where am I going? Nowhere, because a B doesn't have any transition. Clear? For B, 0 doesn't have any transition. Okay, it again. I'm in a state called B. I have an input symbol 1 on it. Where am I going? I'm going to a state called C. B upon 1, I'm going to state C. B upon an epsilon, where am I going? I'm going to a state called D. Is that clear? State called C. 0, it's been not defined. Okay, if I use 1, it's been defined, so hence I'm going to a state called D. In C, an epsilon not defined, hence I write null. Okay. Next is state D. In a state D, 0, 1, and epsilon, all three has been not been defined. I write null and null. Clear, guys? I'm in a state called E. Here goes the things. I'm in a state called E. If 0 comes, I'm going to a state called F. Clear? Perfect. I'm in a state called E. If I get a symbol 1, where am I going? No way, because a 1 is been not represented there. I'm in a state called E, I get a symbol epsilon. Where am I going? I'm going to a state called B and C. So I represent BC in one resource. Clear, guys? Okay, now same the last one. F upon 0 is B, F upon 1 is null, F upon epsilon is null. Clear? Let me explain you a few more things. What I say, a theorem or terminologies as we represent. Okay, a regular language to an epsilon NFA. What do you mean by union? Union means say when I'm joining a language E, when I'm in language E2, E1, E2 language, one language which contains the string A, one more which accepts the string AA. These are the two expressions what I am saying. When I say about union, this is what we represent as a union. Here, I am clubbing both the language. I am going to a next state, and this is called as a property of union. Clear, guys? Okay. Next, what is the property of? Okay, as I said, this is a property of union. So here I write as E1 union E2. Okay, now next property is a concatenation. What do you mean by concatenation? I take a state called E1. I take a language called E2. Concat. Normal English definition of a concat is append each other. I use the echelon transaction from one state to another state to pass, and that's it. This is concatenation. The definition of concatenation is E1 E2. Clear? There I have been represented as E1 union. Here I write as E1 E2. Class is a property, is a closure property. What do you mean by closure property? Okay, let me take an example as I'm in a state. I use the language E. Is a closure property. Hope you guys remember closure meant to say what I've been saying you. It's a representation of a star. All together forms a star. Star meant to say it's an infinite loop. Here, a language E can iterate n number of times. I can iterate language E n number of times, and hence I use a set loop. And if I don't use anything, I'll go to a final state. And these are the properties and a definition of NFA and an epsilon NFA. Okay, last thing, as I've been explained about an NFA, as I've been explained about epsilon NFA, and the previous sessions I've been explained about a DFA. Now let me tell you a difference between, this is the normal question which will be asked in exam. What are a difference between DFA and NFA? Here you guys can write easily the difference. For example, every input string is of a finite automata. I meant to say in a DFA, if a symbol A comes, I'm going to a Q2 or a Q3 or a Q1. This is called a DFA. In NFA, if I get a symbol A in a state called Q0, either I might go to a Q1, Q2 or Q3. This is called an NFA, and hence I write it can go more than one state. Okay. A conversion of a regular expression to DFA is a bit complex. What do you mean by regular expression of DFA? For example, I'm getting a regular expression as A, B, B, C, C, D, D, or for ABC, not end with A, B, which has a combination of 0, 0, 1, 1. This is called a regular expression. To construct the expression in DFA, it's been a bit complex when you compare to an NFA. Clear? Okay, now the next one, third point. The DFA requires a more memory to traverse the string. Okay, for any string to be traversed, DFA requires more memory because the memory bit is been more. But here in NFA requires more computation to match a regular expression with input. Here, that meant to say, for example, if A, B, B, A, B comes, for example, I take a string A, B, 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 A, B. Okay, to that I need more memory for in DFA. When you compare to an NFA, it requires less memory, but one thing is the computation task is more because I will never come to know which state I am traversing off. Okay, the last to next state without any symbols. I meant to see if there is no input symbol accepted for a DFA, it will never flow from one state to another state. But in NFA, even if there is a symbol or without any symbol, it can travel from one state to another state. I hope everyone are clear with it. And guys, this is all about an introduction about NFA and DFA. Thank you.